Hello and welcome to the Teardown Sessions. I am your host, Helen Leigh, and today we are welcoming Greg Steiert of Intel's Altera. We're going to have a fantastic giveaway, which I'll bring Greg on momentarily, and we can talk about that. But before we bring Greg on, as usual, I am going to show you what is going on at CrowdSupply briefly. Got a few things happening at the moment, some fun things. So live right now, we have this delightful ESP32 Rainbow. This has been popular on the internet. So it's a ZX Spectrum single board computer, and this is a really nice job they've done on silkscreen. This is their PCB design skills are excellent. So anyway, that's a fun one if you're into that. If you have a Bamboo Lab X1, this is a must-have. People loving this. It's an expander board for your printer. You have a P1S, not a carbon. But then we have the USB Insight. I hope that's also being raised at the moment. Also hit its goal, doing very well. Good job, guys. And it says what it is. It's a USB interfacing tool. There we go. This one's one of my favorites on the site at the moment. This is called Solder Ninja Pen. I really enjoy it. It's a USB-C soldering iron, which is the best kind of soldering iron. But the thing about this that I really like is it is compatible with Weller RT micro tips. And I am a Weller girl through and through, so it's really fun to be able to add a USB-C portable soldering iron into that I can use my existing tips with. And also I have got one of these in real life. I've been seeing it around for a couple of years. I saw it at SuperCon, I think, a couple of years back. He brought the prototype. But it's really nice. It's machined aluminium. It feels nice and weighty in your hand, but it's quite small as well. I am very much enjoying my Solder Ninja Pen, and that's doing well as well. So you hit your target with 7 days left. So if you want one of those, you can get them there, or of course we will hold them in stock once they are produced as well. What else have we got going on? Finally, yes, Signaloid has got a tiny little programmable FPGA system on module SOM in the micro SD form factor, which has smashed its goal as well. And it looks like they've just added LiteX support as well. That's dope. That's cool. Yeah, great. I love a bit of LiteX. So that's doing well as well. Again, what have we got left? 14 days left on this campaign. So if that sounds interesting to you, please go along and support their work. All right, that's what we've got live at the moment. We've got some fun things coming up, though, that I wanted to share with you. So if you are in the area, in the Portland region, where our office is, we are having a holiday party tonight in collaboration with Portland's Hardware Happy Hour, which I run, the Portland Hardware Meetup, and Dorkbot, which is another hacker meetup that happens at our Control H, which is our local hackerspace. So if you are around and in the location, you are most welcome to come and raise a glass with us. All the details for that are on the website, events/hackerholidays. That is tonight. One other event that we've got is very exciting. We've launched it very far in advance. It's Teardown 2025. The dates are public and ticket sales are live and the CFP is open. So please go and check that out. We have already announced our keynote speakers. I'm very excited that I've managed to book these people. But so our Friday keynote will be Cory Doctorow. Our Saturday keynote will be Kate Stewart of the Linux Foundation and Zephyr and RTOS, lots of great stuff in her background. And then the infamous Bunny Huang, who is a hardware hacker and author, and releases all of his hardware with CrowdSupply, actually. So it's going to be great to see him. So those are our keynotes. It's going to be taking place in the mall again. If you didn't know, we held it in a semi-abandoned mall in the heart of Portland last year, and it was epic hacker vibes. We had a great time. So come and join us if you like. We expect to sell out this year, and it's currently early bird ticket sales, which is a full $50 less than it will be probably in January. We'll switch that over. So Teardown 2025, it's we've got the talks, we've got the workshops, we got an art exhibit, and my guest today was one of the most popular workshops from Portland 2024. he did a fantastic workshop. I think I was actually one of the first to sell out to build a $5 FPGA loader. So he used the, I'll bring him on in a second to let you talk you through the workshop, but yeah, it was really popular. And hopefully we'll be able to persuade him to come back. As well as doing the workshop, he works for Altera, which I'm sure he'll tell you all about. But rather than put words in his mouth, let me bring on Greg himself. Add to stage. Hello, Greg. Say hello to the people.
Hi, everyone. Happy to be here.
Would you like to introduce yourself and tell to people what you're about?
Yeah. So I'm a technical marketing engineer at Altera, and I was the one who helped us get our crowd supply hub set up this past year, and I was really proud to be able to be active at the Teardown this past year, and came up with this workshop, which was happy.
It was so good. It was so good. You did a great job.
It was it was a lot of fun, and I'm going to walk through a lot of that. I've got a broad background and kind of a history with crowd supply and Teardown that I'll touch on in a minute here too. But that is a great lineup of keynotes you got set up for this year.
Thank you. I can't believe they all said yes, frankly. Yeah. But you know, I got what I asked for almost.
Yeah, I already got my ticket. I recommend everybody goes. I can't talk about this enough, but
it was fun. It was fun. It was fun. So tell us, let's rewind a little bit. What's Altera? And what's the relationship to, tell us a little bit about Altera and also the relationship with Intel.
Yeah, sure. So Altera is one of the top FPGA companies. They were acquired by Intel, and now they're in the process of being spun back out into a separate independent entity. So if you don't know Altera, they make FPGAs. So these are field programmable data arrays. There are arrays of logic that you can kind of turn into your own chip. And actually, we'll be giving away a dev kit, which is actually part of the kit that we gave away.
We will.
That we gave away to the people who participated in the workshop. So you'll be able to.
Should we take a pause and tell people about this? Tell people about this giveaway. Okay. So how many? Do you tell them what we're giving away, and then I'll tell them how they can win it?
Yeah, and if you share my screen, if you want to bring that up, I've got a picture of it right here.
That. Here we go.
This is the kit. So we've got an Altera Max 10 evaluation kit, and this kit didn't come with, doesn't have a built-in programmer. So what we did in the workshop is we used the $4 Raspberry Pi Pico board to program it. And then I'll talk through all that. But the part of Max 10 is just a great part. We recently extended the life cycle of this out to 2040. So these are still recommended for new designs. And one of the things, if you look carefully at the board, you'll notice the part is QFP. We still make FPGAs in QFP for the people who want maybe a 2-layer board, easier routing. So great part for that. The nice thing about this also is Max 10 will run single supply. So you only need to give it like 3.3 volts. You can put soft processors, and it's got onboard flash. So really you don't need hardly anything else outside the part except maybe a crystal if you need an accurate clock reference. But all the flash is built in, so you can use the flash. It's got a lot of extra flash, so you can use it for the processor code or to store some data. The Max 10 even comes with analog to digital converters. So there's a lot of features. It's and some of the smaller ones don't all have multipliers, but this one has hardened multipliers in them too.
Nice.
And people who maybe haven't used FPGAs as much as, or maybe you're more familiar with microcontrollers, a lot of microcontrollers will only operate, their I/O will only operate at 1 voltage. In FPGAs, it's broken into banks. So you've got access to things like differential signals, and they can run, anywhere from like 1.2 volts up to 3.3. So very flexible devices. And yeah, so PLLs, so you can do clock conversions, all sorts of stuff. So they're great, like kind of glue logic chips to mop up all the other functions on the board that your other chips may be lacking. So enough of that. But this is the kit we're giving away. And I'll let.
How many? We got 1 to give away, or we got 2 to give away? I don't know.
We can give away 3.
Oh my goodness! You're spoiling us. 3 kits. All right, great. Yeah.
Go ahead.
So shall I tell them how to win it?
Yeah, go ahead.
All right. So the way we do it on this stream is I have written down 3 timestamps on a post-it note in front of my computer here. And the person who leaves a comment or question closest to the timestamps on my desk will win this kit. So please keep your questions and comments coming in, and you could win this. That'll be fun. And before we move on to talking a bit more, I wanted to say hello to some of the people who are here in the stream, who are joining us. So we've got Antish Singh saying hello, nice waiting. And I saw that come in at 9:39, so you really were several hours early, so very enthusiastic there. Timon in the building, one of Crowd Supply's creators and a good friend of mine. Nice, thank you for joining us. We've got FPGA Zealot, who I believe is Andrew. Trying to remember all the handles with the actual name. So hello, nice to see you. Drew Festini from Tanstorrent and Osh Park. Hello, nice to see you. Hector Vidalis, nice to see you as well. Thank you for joining us. Drew says, oh, he's happy to see that Corey is going to be working, headlining, one of the headliners at Teardown. Yes, me too. Timon says hi to Greg, and then Suraj also says hello as well. So thank you all for joining us, and please do ask us questions as this goes on. All right, so Greg, I believe you have some information to share with us about the. Where are you going to start? Are you going to take us through the workshop? Are you going to take us through your code first? Like, what's your plan? What do you want?
To start off real quick about these kits, we do actually have a few more kits to give away. And one thing I want to do is just encourage everyone to sign up for Altera Innovation Lab. You can see there's a subscribe feature there. So if you want, if you don't get one of them today and you want another chance, we'll be sending out some more opportunities there. And if you follow me on social media, I'm on LinkedIn, Twitter, Mastodon, all that stuff. So if you follow, there will be more opportunities to get some more of these kits. We want to get these into developers' hands. So happy for that. Again, this is the kit. It was the workshop. So great timing that the Teardown 2025 was announced just before this, because I'm actually going to talk about how I came up with the idea. So those of you who are thinking the call for papers is out. It is indeed, yeah.
We call it the call for participation. We're not academics.
Okay.
but you can give us your papers if you like as well.
Great point, but maybe this will give you guys some thoughts of where to get ideas.
Yeah, absolutely.
A little bit background on my history, and this will play into how I came up with the idea. So some people will notice me if you saw me at the last Teardown. I'm the guy with the noisy business card and the funny logo. But I was pretty proud because I've been working on iterations and iterations of this business card. At first, it just blinked, and there's no battery. It harvests energy from NFC. And I finally got it to beep. And like in 2023, people were telling me the card was too thick. So this year, I came with one that beeps, but it's less than 1 millimeter thick. So I was pretty proud of that. I got it.
Is that flex that you're using?
It's Osh Park flex even.
Nice. Love a bit of flex. I'm a sucker for a flex PCB.
Yeah. But the way this ties in is I've got a background. I've done PCB design, and right now it's kind of a hobby. I really enjoy doing the PCB design, which plays into the thing. But this project, if anybody wants it, all this stuff's open source. You can see it online. And how it ties into Teardown. My first Teardown was 2019. And somebody saw my business card, and I actually designed the badge for the 2019 Teardown. So it did my blinking business card circuit was on there. So that was kind of my first Teardown. I think I had one before that I missed, but
that was my Teardown as well. My first Teardown as well. I gave a talk, and that's how I first heard of Teardown and Crowd Supply. And now I run Teardown. How funny is that? But yeah, 2019 was my first Teardown as well. But I think the first Teardown was 2018.
Yeah, I think so.
Yeah.
And this was cool. They put a key was encoded in the NFC, so that
Yeah.
Teardown does. Do you want to explain the puzzle hunts or something they do?
Yeah. So one of the things that we do, there's all sorts of fun and quirky things about Teardown, but one thing that people love is we do a scavenger hunt that has it's puzzles all across Portland, and each puzzle clue leads to the next puzzle clue, and some of them are embedded within various things that you might get at Teardown. We've had puzzle clues inside the t-shirt designs. We've had puzzle clues in the badge, as you can see here. We've had puzzle clues like with stickers that we put in the little swag bags, you know. So there's all sorts of hidden little trinkets that you can decode, and people do love that. We do try and we have like a lot of after parties, and they're not all revolving around let's go to the bar and drink. You know, there's fun activities as well. Yeah. But yeah, that's the puzzle thing.
Yeah.
And yeah.
So they worked. Yeah, this was part of their puzzle hunt too. So that was a lot of fun.
Yeah.
And then in 2023, the COVID stuff, they skipped a few years, but in 2023 they brought it back up. And in 2023, oh man, my computer is not switching tabs right now. What's going on? Anyway, I can talk through. In 2023, I gave a talk. Is the video still coming through?
Your video is still coming. Wait, hang on. I'm not sure. You've kind of paused.
Okay. Yeah, my connection might not be great.
Yeah, so, that's okay. We'll survive. I can still hear you. So why don't you just keep talking, and hopefully your internet connection will wake up.
Hopefully, okay. I think someone's doing that. Okay.
Yep. There we go.
So in 2023, I gave a talk on I called it Adventure in Flash Loaders, but it was really about implementing the UF2 file format, which is a drag and drop file format, and that will work its way into this story too. I'm just giving kind of the backstory.
Yeah.
But the real thing that triggered the idea for all this was Patrick Ducid, and sorry if I butchered his name, but he ported dirty JTAG to the Raspberry Pi Pico board.
Yeah.
And that's a really popular $4 board. And I'm like, oh, and dirty JTAG works with openFGPALoader.
Oh, it uses the PIO unit, the PIO. Interesting. Okay.
Yeah, but so I'm like, oh, so it works with openFGPALoader. Well, I can make an FPGA loader using this with our Max 10 board that doesn't have the programmer on it. So I'm like, cool, this is great. And then I get to design a little adapter circuit board to match the the Pico Dirty Blaster is the blaster adapter I created to convert the Pico board into an Altera programmer. So this maps the pins along the side that he defined for JTAG to our blaster pinout, the same pinout that's used on our dev board. And I just got to say, OshPark is great for these adapters because it's like a tiny board like this is like $1.50 and you get 3 copies. So a 2-layer board, a really simple design, but you get a custom circuit board. So
yeah. Hang on, Greg, I've got a so Timon has said if you disable and re-enable your camera, it might just fix it in StreamYard.
Thank you. Yeah, it popped back, but I'll keep that in mind if it happens again.
Yeah. You can keep talking though. I can see your tab. I can see your tab. Your screen's coming up fine. So, it's just your face is frozen.
Okay, great.
Yeah, it's fine. We'll do it later. That's fine. Carry on.
Disable the camera, not right. Great. Yeah, so with that, I designed the adapter. So that's the adapter unassembled. This is the adapter assembled. And this is one of the steps people had to do in the workshop was to assemble this. It's all through hole, so it was a great beginner soldering test. And it's actually all through hole, although I did recommend people do the castellated pads on the back just as an extra sturdy in case the solder didn't wick all the way through. But so this was the circuit board, and that was kind of the inspirations. I saw, oh great, there's this tool, now they can program our FPGA board, and there's a little bit of soldering for people to do, and I knew Crowd Supply usually had a bunch of soldering irons at these events. So
we do, and we're going to have even more this next year.
Yeah, so
more.
It seemed like a great idea at the time.
Oh, I think we've lost Greg entirely. It seemed like a great idea at the time, and then
my camera. Oh, there we go.
Oh, here we go. We've got you back.
Sorry.
Great.
Yeah, it seemed like a great idea at the time, but when I got it and I was testing it, and it worked, but it was just painfully slow. I mean, it was embarrassingly slow because, and I'll get a little more detail about SVF, but there's a serial vector format that openFPGA used to program the Max-10 device. And it's a very rudimentary, it's almost like an ASCII recording of all the JTAG transactions. It's extremely slow to implement. So after my first panic from the fact that, oh my gosh, I signed up for this workshop and now my prototype is just not usable in the way I intended, I was also thinking that, hey, what the Pico Dirty JTAG did is it just implemented a very basic USB to JTAG adapter, and it wasn't really taking advantage of the microcontroller. Like it wasn't even, it was doing a poor imitation of an FTDI device basically, and it was really slow. And I can tell you the problem isn't inherently SVF, because I also created another adapter that actually works with the Tiger board to the
nice.
Altera pinout. And I did the same thing with openFGPALoader using SVF to program the Max-10 with this. That was slow but usable. And this gets into the some of the limitations of the Raspberry Pi Pico, their microcontroller. One of the things when they released the new one, I was really disappointed that they didn't upgrade the USB to high speed, because that's one of the things. The FTDI chip operates high speed, and the Raspberry Pi Pico is still full speed. So that may have been one. I didn't. There may also be some protocol implementations on the bridging, but for a couple of reasons, it just wasn't really usable in that form. But yeah, but just I also tested the SVF with this other adapter. I think I actually designed this adapter after Teardown just to test it. But this is available. All my stuff, I'm posting everything on GitHub these days. This one's available on GitHub if anybody wants it. If
what's your handle? Is it just Greg Steiert?
G Steiert is my GitHub. Although I also, for another reason, STEIEIO is also one of my GitHub.
Nice.
That's a long story, but that's it. But yeah, so this works, but the one I originally intended with the Raspberry Pi Pico, that just wasn't feasible. So I got the idea, well, it's a microcontroller and we can do so much more with it. Maybe if it interpreted the SVF directly, it could program it faster. But then I was also thinking, I was looking for some SVF code, and I never found an SVF, some open source code that really met all my needs. And I was looking at what other code options were out there. Now, actually, Altera provides some code as well, not necessarily for SVF, but for a couple other formats like STAPL. So now let's get into some background. What is SVF STAPL? So Intel actually has a nice write-up that talks about the difference between SVF and STAPL.
Before we get into first of all, I can hear an echo. I don't know if other people can hear me twice. Are you able to use headphones, or I don't know? Actually, the echo seems to have gone away again. Okay. So that seems to be okay. So that's but also quite amusingly, This was this was the the comment closest to the first timestamp that I had written down. Oh no, by James Meach, and that happened just as you left. You disappeared for a second. So this is the first winner of today's giveaway. James, if you can get in touch with Greg, how can we get in touch with you?
Yeah,
on social or?
Yeah, you can LinkedIn or X, some FPGA helper on X. Either of those will work.
Okay. Yeah. So James, you're the first winner. If you can get in touch with Greg, we'll get that sent out to you. Okay, cool. Thank you.
Congratulations. Yeah. So getting to trying to find a better solution and make better use of the microcontroller. So SVF was one option, but it's kind of limited. And like I said, it's just kind of a log of all the transactions encoded in ASCII. So the files are huge and it runs kind of slow. So Altera years ago came up with a better version. They actually called it JAM, but it's actually been turned into JTAG standard. So it's the STAPL, the standard test and programming language, is now a JTAG standard. And this has actually been implemented by other FPGA vendors as well. So it's not just an Altera thing, although Altera created it, but it's open. It's an open standard now. Mm-hmm. To go with this, there's a couple implementations. A lot of times Altera will call it JAM. That was their name before the standard, but they're equivalent. Also part of it is JAM is ASCII based, but there's a bytecode version called JBC. Well, yeah, JBC, JAM bytecode, where they encode it and it gets smaller because they're not using ASCII, they're using bytecodes. Altera also provides some embedded code to implement this. So this was created years ago, and it's made freely available. It's intended to be used in customers' applications. The actual first release was a little bit kind of predates some of the popular open source licenses. So the license is a little ambiguous, and we're working to fix that, but it's not out there yet. But it is available free to download. Just kind of the click-through thing, but you can download the source code and implement, which is what I did. I downloaded it and I ported it to the Raspberry Pi Pico, which is actually pretty uneventful. And if people are interested in that, you can reach me offline and I'll help point you. I actually have a link to the download here. This is the download page for it. One interesting thing with this page, it's got a few different codes on here. You got to make sure to get the JBC player. You select version 2.31. If you select 2.61, that's the JAM player, which is the ASCII-based one. So if you want the bytecode, that one's here. But if you download this, it's code that's pretty clean and pretty easy to port. It tells you which pieces you need to generate to customize for your hardware. So I took care of all that and created that. But a couple other things that were interesting about implementing JBC on a microcontroller. One of the problems is these files, especially like SVF is huge, JAM's big, JBC gets smaller. So with microcontrollers, they're resource limited. So they have limited amounts of RAM and flash. Unfortunately, the Raspberry Pi Pico has a 2 meg flash chip on board, so that's plenty big enough to hold one of these JBC files. But the trick is there's not enough memory to hold it in RAM, so you have to use it directly from the flash, which is important because another thing, like with SVF, you have to process it streaming. So you could actually like stream it over USB and work on it sequentially. But with the STAPL, the JAM, it's actually kind of a programming language with like branches and loops. So you have to actually be able to go back in the code. So you can't just kind of like stream it through a COM port because it actually has to save it up because it might have to go rerun that again, which is part of why it gets smaller because it can run loops instead of typing out, 10,000 zeros. So that is important there. So the file is big enough to fit in the Pico, but it won't fit in the RAM. It would fit in the flash. And another important thing is the Altera tools still create JBC files, but there's a trick to getting uncompressed JBC files. Because another thing they did to shrink the JBC files is they added the option for compression. But the problem in the microcontroller is if I put the code, if I use the compressed version, I would have to have enough memory in RAM to decompress it. Or even if I decompressed it to flash, I would have to have the 2 copies of it, essentially. So the compression hurt me more than it helped me. So I needed to figure out how to get the uncompressed. So if you go into Quartus, there's some options for building that. So first you got to go into the product, and then you open the device options and device and pin options, and then there's an option for creating things like SVF and JAM or the STAPL bytecode. Do not select the bytecode, because you can see, if you look carefully, it's grayed out. You can't uncheck the compressed box, and the compressed won't work for this. But if you create the JAM file, then they have a utility that can convert JAM to JBC. So this, I've got a link to this, how to create these files. I documented it all. It's all automatable. It's just a command line utility. And technically, like I said, some of our competitors implement this. I don't know if they create JBC, but I do believe if they'll create the STAPL, and if they don't do the bytecode, you could use this utility to potentially convert it. But that was important. And another thing with the Max 10 devices, it creates 2 outputs. One output is for programming the SRAM, and a second output is for programming the flash. So if you want it to remember the image and to load up with it the next time you power on, you need to make sure you grab the JAM file with the POF, because the POF is the one that targets the flash instead of SRAM. So a couple quick things there about creating the JBC file. So, that's how we get the JBC file. And the JBC player is how it plays it. But then the next challenge is, how do you get the JBC file into the Raspberry Pi Pico flash? And this is a trick where you could write utilities, and I don't know, I hate installing stuff on the computer, and I wish everything was as easy to use as a thumb drive. So I'm a huge fan of the UF2, which is why I talked about it at the Teardown 2023. So I'm like, another great thing about the Raspberry Pi Pico, they baked UF2 into their ROM. So it can update its own flash. It's just in the ROM. You can't even corrupt it because it's in ROM. So,
yeah.
I was like, I knew it had that capability, and I'm like, oh, well, I can convert the JBC file to a UF2 file. And drag and drop straight into the part. But then I was, and technically you could use the, like when you're building the Raspberry Pi Pico, the firmware image, it creates a UF2 file because that's a standard way to load it. So I could just drag that one there, and then I could use a standard UF2 utility to copy the JBC file, just because it's a binary file. I could just copy it. I could convert it to UF2 and then just load it. But a couple problems with that. One, the code, the firmware, not only needs to know where the file is, but it also needs to know how big the ROM, or how big the JBC image is. That's key to the the JBI player code. So I had to add in the file size. So I basically, what I did in the code is I added a header to the before the image that said how big the JBC image was. So I flipped, I added a header to that. And one of the nice things about the UF2 format, and I don't want to go into too much detail, you can watch my other one to get more, but it basically breaks, the FAT file system sends 512 byte packets.
Mm-hmm.
It basically formats everything into a 256 byte payload in a 512 byte packet with some overhead. So what I did is I created a 256 byte header that had the length and actually had some description and other information that I used in the code, and prepended that to the front of the JBC file before I converted it. But then I was worried, the firmware, the JBC player code needs to kind of be compatible with the JBC image you're using.
Yeah.
Because if you have different versions, things might change, or the header format changes. And I didn't want to have incompatibility issues. So I thought, you should probably program these together. You shouldn't program them individually. So I decided that I wanted this to create a single UF2 file that would program the JBI player, the header, and the JBC file all into the flash at once. So that's the code that I want to talk about the details of, because I learned a few kind of key things, some things that weren't documented along the way to get there. So again, we talked about the one chip to flash them all, the UF2 format, lots of stuff there. And that leads up to, I created this JBC UF2 converter. So to do this, I started with the UF2 creation utility that the Microsoft created for their make code. I took that and I modified it to create the JBC file. So I created this command line utility. You give it the Pico, the UF2 file for the ROM that I compiled, where I compiled the JBI player for the Pico. You give it that UF2 file. You give it the JBC file, and then you need to give it the start address for that you want to put the JBC file at, and then there's a couple strings that you can give it that also go in the header. So this is a Python script that does all this, and I'll walk into how it does this a little more. I've got the code up here. So and if is anyone asking any questions or anything along the way?
Just people agreeing with your approach, saying it makes sense to program together. And Timon says he loves UF2, such a simple and useful format.
Yeah.
I should say that Hector Vidalis commented at 12:36, which was another time stamp on my post-it note. So Hector Vidalis, you are the second winner of today's Altera development board stuff. So please get in touch with Greg and he will sort you out. All right. Thank you.
So so I'm going to go through this Python here.
Great.
And walk through what I learned along the way.
You're welcome.
In the UF2 headers, they put the number of blocks that I expect to be programmed in there. So when I wanted to concatenate to the UF2, because basically I was going to start with the UF2 firmware one that the Raspberry Pi SDK created, and then back to it. But I had to go back and touch every packet to update the number of blocks. I don't know if they actually checked that, but I ran into a bug along the way and I made it do it. So it's accurate now. So I set initialize some stuff, but I go into this. I have to update. There's the UF2 blocks in, and then there's the blocks out. So the number of blocks, Yeah, I take the UF2 blocks out. And the reason the blocks out is different than the blocks in, I guess I should cover that now. One of the things that took me days to solve, I was trying to concatenate the two, and I just, as soon as the Raspberry Pi firmware image stopped, I would start writing the JBC image immediately after. But I found out that every time I did that, it was always stopping at the end of the firmware image. Now, when I did that, I would jump to another address because the JBC was at a fixed address further down in the code. So I thought, oh, maybe it's moving the address. Maybe I need to pad it or something. But I actually discovered that, and this is different because I worked on the tiny UF2 that Adafruit created.
Oh, nice. You did. Great. Thank you.
I ported a couple of micros to that, which is what I talked about in the other one, teardown presentation.
Yeah.
But the Raspberry Pi one did something a little different. In the Adafruit Tiny UF2, they have a cache block where when you're writing all these blocks, it basically saves up a flash erase page so that if you wrote something out of order, it would, when you jumped between cache pages, it would flush the old one, fetch the new one, and everything would work if you went out of order or crossed the flash page, erase page.
I see.
The Raspberry Pi Pico, the ROM code does not do that. When it sees you jump past, when it sees you do an incomplete flash erase page, it stops. It'll write that one, but it won't do anything after. So that's why it stopped processing all the packets I added afterwards, was because it wasn't it wasn't a complete page.
How did you figure that out? Like, what was your process?
Trial and error. I mean, I was beating my head against the wall, maybe trying to put in, trying to move the address or something. Or I think I created a couple test cases to try different things. Like, oh, I thought maybe it was the boundary I jumped to. So I tried changing to a wider boundary to see what it could be. But eventually, I thought, oh, maybe because I'd worked on the other one and I knew there was a caching in there. I thought, what if they implement it differently? Because it did write. I think the thing that triggered me was it did write the bytes, a partial erase page, but it wouldn't write anything more. So, but that one was tricky. Like I said, I beat my head against the wall for a couple of days trying to figure that out. So once I figured out how many packets was an erase page, I had to look for the mod of that, and then I had to add in packets. That's why the blocks out and the blocks in can be different. So I had to do that, and then I had to add the JBC blocks, and I had to add one more block for the header that I added. So that was one of the big pieces there. Then I didn't want to have the user to have to enter in all the family ID and stuff. That's already part of the Raspberry Pi SDK already puts that in theirs. So I didn't have to enter any of that. I just copied it from the input, the UF2 file that the Raspberry Pi SDK created.
Yeah.
I went through all their blocks, and I go through and add the padding at the end. Then I've got, I create my header. So in my header, actually somewhere along the way, I can't remember, there's some check code in there that as we're parsing the input file, we check for some inconsistencies just to flag some errors if it wasn't a valid UF2 file. That was probably part of the UF2 utility. But there is some checking in there. And I did put a comment, the flash erase sector size in here. So I'm adding the blocks, the spacer blocks, just to finish the erase page so that I can jump to a new address. Mm-hmm. So that's in the code. And then I created a structure, and in the the JBI player, I added that structure there, that some of my code in that one will read this packet. And so this tells it how long the JBC is, because that's a key factor. Now, another thing about the jam player, these jam files can actually have multiple actions within them. So there could be like an erase action and a program action. I only use the program one because that's the most popular one. So, but in theory, you could have a JBC file and you could send it kind of a different command, like a, you could send it like an erase command, or I don't know, device ID, but it supports multiple actions in there. So one of the things, there's a string that lets you pick that lets you pick the action. And I see question, no signal tap debug support. The Pico code, that was running on the Raspberry Pi Pico, not the FPGA. So I would have had to use their debugger, but just background on me, I've got mostly a hardware background, and I'm one of those guys who beats his head against the wall with printfs.
You and me both. You and me both.
I can never remember all the GDB
Serious.
commands. I try to once in a while, but usually it gets flushed from my cache too often. But it's also tricky because their ROM code, I need to look to see if they publish their ROM code, because I don't know if I have access to the source to do the debug for that. Very good question.
Cool.
So I put the header. Oh, and I have a string. And actually, when you're using this, if you connect the serial port, if you connect the serial port while it's programming the Max 10 device, it actually puts printf messages out on the JBI code I implemented will do some printf messages on the serial port. So it'll actually give you some debug information if your Max 10 didn't program. There is some information on the serial port. You don't have to look at it if everything works, but it is there. And it is one of my goals to make my Raspberry Pi Pico implementation public and open source. I'm just waiting for Altera to update the license terms so that I keep everything above board. It's agreed in principle. We're just trying to get the code updated through the bureaucracy.
Sometimes it takes a lot of bureaucracy and a lot of meetings to release code.
And with all the
it's true.
All the transition that's going on, separating the separate entity, everything's So
thank you for fighting that fight from the inside.
Yeah,
it's appreciated by the open source community when people,
the code is available to everyone, and if there's people who want it in the interim, please reach out to me. I don't think there's any problem with sharing it individually. It's just publishing it that's
you need to get a bit more approval from.
So so I add the header, and again, I made it intentionally exactly 256 bytes, so it would be one UF2 block that I could insert, and the Python script builds it for you based on the command line options. And then you send it the file, and it just it just does the same stuff the standard UF2 utility does, converting 256 bytes out of the JBC file and adding the UF2 headers. So pretty basic. A lot of that stuff goes. Again, I started with the UF2 generate utility Python script from the UF2 project.
Very cool.
And that was there. Those are kind of the interesting parts from that. And then that was what I used in the workshop. And the workshop, again, I like to push everything onto GitHub. So I actually put the workshop instructions are available on GitHub.
Nice.
So anybody who wants to do this at home, the instructions are up. And I provided a couple example files, and I use open source programs for the examples. So the board is available in the LED to Believe, Olaf Kindren's. It's like the Blinky. It's the Hello World of FPGAs. So this is one of the over 100 boards that you can target in that project. So this board is in there, and that was one of the demos we used. I actually used a couple copies of it where I moved it to a different LED. There's also Servant, which, funny enough, is another Olaf Kindgren project where he has a little bit serial RISC-V core that he does. And another great thing about UF2 is something, I had some extra credit in the workshop. So links to creating all the files and everything are there. The Dirty Blaster, if you want, you can buy all these boards. The project and the GitHub source for the adapter is on Archpark. Again, it's like $1.50 to get the board, $4 for Raspberry Pi Pico, and like 50 cents for a header if you don't have one in your library. It's really low cost. That's here. It shows you how to solder it. And getting through what they did on the board, it was drag and drop. I gave them like about.
This is great, Doc. You did a really good job of explaining it. A lot of people don't go to this extent of documenting it all, so good job. It looks great.
And basically, they could drag and drop different images that would blink a different LED with the extra credit. And again, another great thing about UF2 is I did post the Pico Dirty JTAG and gave them instructions to how to load openFGPALoader. One of the nice things about the Pico Dirty JTAG, not only does he do the JTAG, but he also includes a UART port. And so we use the same board as a UART adapter. So when you loaded the servant file that does the hello world, there was a jumper wire you could connect to view the printf output using the Pico Dirty JTAG. And to switch between programming and Pico Dirty JTAG, there was both just drag and drop. You activate the bootloader and you just drag Pico Dirty JTAG. Now you have a USB to serial adapter.
Nice.
The final extra credit was actually waiting for SVF to complete. I mean, I want to say it was on the order of 10 minutes. Honestly, I never officially timed it. It was just like more than a cup of coffee in a bathroom break to finish. But it does work.
Very cool. Very cool. Well, thank you for talking through this. I wanted to, another amusing winner. So the closest to my final timestamp on the post-it note was Mateja Milosevic, who says no print Fs. That was the closest to my final timestamp. So Mateja, I'm sorry if I'm butchering your name, please get in touch with Greg, and you will get one of these devices to run through this workshop on your own. Have fun. And then a lot of extra credit. We haven't got a question from Bonhomme 2. Greg, did you ever try programming the analog pocket?
That's on my bucket list. I almost bought one, but had some credit. Yeah, it's just
explain what it is for those people who don't know.
Great, yeah. Analog Pocket is an FPGA board. It's kind of like it's a portable. It's a very clean, nicely done, professional looking, kind of like a Game Boy type thing, but it's an FPGA based open hardware kind of retro gaming system. And there's that one, and then there's also the Mister project, and these both use I think they're Cyclone 5 SoC based FPGA boards inside them. The Analog Pocket's nice because it is a very professional looking, and you can program it, and it's open source, so you can develop for it. The Mister project's another good one to look at as well. And Teresa,
I also had a comment. Sorry, I had a comment from Andrew's own FPGA zealot saying that the analog pocket voltage will need to be considered as well. He says only the dev version of the pocket has a JTAG connector exposed. Oh. So interesting. Thank you for sharing your knowledge there, Andrew. Okay. Yeah, cool stuff.
I need to make sure I do that when I try to get one.
Yeah. And just to be completely clear, because Raspberry Pi does have some new silicon out, we're talking about using the Pico with the 2040 microcontroller on it. Yes. the RP2040. So there's new silicon coming out, and I wondered if you'd done any work, or if you think if you would consider porting it to the 2350 is the new number?
2350.
Yeah.
So the code that I have compiled is for the RP2040, the Pico 1. There's a Pico 2 with the 2350.
Exactly.
It should work for that. I haven't compiled it yet, but it should work with that. I plan to do that. The funny thing is, I've got another project. I'm working with somebody else, it's loosely related to crowd supply, but I'm pairing up the 2350 with the Cyclone 10 LP. And one of the tricks I want to do is on the 2350, so they use a quad SPI to talk to external flash. The 2040 and the 2350 both do that. In the 2350, they added support for PSRAM on the quad SPI bus.
What's PSRAM?
Pseudo.
Pseudo RAM. Yeah, sorry.
Yeah, so basically it's a quad SPI, but it's like you get megabytes of memory. But instead of DRAM where you have to do the refresh, it looks like a quad SPI SRAM, but it's built more like DRAM inside, but it hides all the refresh stuff from you.
Timon says, in theory, any project targeting the RP2040 should work as is on the RP2350.
Is that binary compatible?
And also, the new Poco apparently has some problems with the pins. I have heard that as well, but I've also heard that there's been some work to work against that.
For what I'm doing, the problem with the pins, I think, was with if you were using the dynamic pull down, and I don't know that the JTAG port uses that, so it may be, but I may have to try that. I've got a 2350 board. Anyway, I'll have to play with that. That is a good thing to try. But I am, again, because the 2350 adds an extra chip select so you can talk to a PSRAM and another address space for it. I'm hooking that up to the FPGA so that I could use it as an FPGA interface by like mimicking the pseudo SRAM over the quad SPI, because quad SPI is pretty easy to implement in an FPGA. So that's something I want to play with. I've got a board that's about 80% of the way to let me try that out.
Yeah, very cool. Oh, wait, I got a reply from Timonsky saying it's not binary compatible, but source compatible. You don't need to change anything in terms of definitions or anything.
But I will need to change something if I want to switch it to the RISC-V cores, though. But yeah, it should be compiled. I should be able to just compile it.
What fun, what fun. Well, somewhat improbably, we've been talking for a whole hour. Funny, ChatGPT might be able to write a quad SPI interface. They might do, whether it'll work or not, I'm not sure. Yeah, right, good luck. So we've been talking for a whole hour, which means we are nearly at the end of our stream. So Greg, is there anything you'd like to leave people with? Where can people find more about this? I'm guessing your GitHub, you've got, what is it, Blue Sky, Mastodon, which of the social medias are you on in today's fragmented landscape, if any,
So, there's links to a lot of the material in the YouTube page. If you go down into the notes there, we put a bunch of links there. The biggest thing I would say is make sure you go to the Altera Innovation Lab and hit that subscribe, because we'll be there's going to be more opportunities to get some of these dev kits if you were one of the 3. Congratulations to the 3 who did. I'm probably most frequently on LinkedIn and X under FPGA Helper, so those will probably get to me quickest. www.steiert.net. It shouldn't be too hard to find online. Search for my name. So
very cool. I would like to remind people, not only do we have that, but we have Teardown 2025. It's going to be awesome. It's going to be really fun. If you want to do a workshop or give a talk or do a demo, we've got lots of opportunities for that. Our call for volunteers is open. Our call for proposals is open. We also have a number of we have subsidized tickets for low income attendees. So please don't let lack of cash stop you from attending this conference. Very practical. Lots of prototyping stuff, lots of small scale manufacturing, lots of hacking, lots of microcontrollers, lots of 3D printers. We have a room full of different machines. Last year we had knitting machine, an X-ray machine, a dye rebonding machine, electron microscopes, all sorts of fun things. So do come and join us if that sounds like your cup of tea. Oh yes, also you can become a sponsor as well if you feel like it. So yep, that's my plug. My leaving plug is for Teardown 2025. I want it to be a good one, so please come and join us. It might be the last one before the mall is demolished, so hopefully see some of you there. And I'd also like to give a huge thank you to Greg for being such an interesting guest, taking us through all your code there and sharing some of your learnings for everybody here. We've had a nice audience of people keeping us company too. Matthias says, really interesting session. Thank you, Helen and Greg. You are welcome. Thank you very much for joining us. And thank you for commenting as well. Makes us feel a bit less like we're shouting into the void. And Hector Vidalis says, thank you, Greg and Helen. Great presentation. Thank you. I agree. Thank you so much, Greg. All right, so the next and final live stream for this year will be, I believe, next week. I need to double check that they're still up for it, but we will be talking with the team from Modos, who are doing really, really cool things with extremely fast e-ink displays. And they were at Teardown last year as well, so I don't know if you saw them, but they're doing some really cool stuff. So hopefully I'll be speaking with them next week. So catch you all later. Again, massive thanks to Greg, and have a happy holidays. All right, see you soon. Bye now.